Good afternoon, everyone. Welcome to another Tech Talk Tuesday here at Treadwell. If you're new to these sessions, welcome. Appreciate you joining. We hold these every 2 weeks on a Tuesday this time, which is 1:30 in New South Wales, where I am. And we just cover a variety of topics suggested by you in regards to Australian standards or applications or uses for FRP or anything else really related to FRP and access and all those sorts of good things. So keep an eye out, and please, if you find this content useful, we really appreciate your feedback. And to those who've joined previously, welcome back again as well. And likewise, you might have noticed come up on your screen today is a poll. We'd appreciate you completing that either now or during or at the end, just in relation to a couple of questions. Firstly, if there's topics you'd like us to look at in the future. Next, if you'll be at Ozwater and if you'd like to come and catch up with us, Ozwater Trade Show, which is at Melbourne Convention and Exhibition Centre, 30th of April to 2nd of May. And lastly, any feedback, questions, comments, any feedback's welcome, good, bad or ugly. So if this was helpful, please say so. If it was a waste of time, please say so. Any feedback's good feedback. We've got a bit of content today, so I'll try and hurry up. Hopefully the voice holds out. A bit of a coldy, fluey thing this week, I think. Not COVID, thankfully, but we'll get straight into it. We'll also hold a Q&A session at the end. Please feel free to put any questions you've got in as we proceed. I've got the chat open, so if we can tie it into a response, we'll do that. If we can't, then so be it. So, also just before we start, by the way, we're at Ozwater not next week, but the week after. As we just mentioned, there won't be a webinar in 2 weeks' time. Our next webinar will be the 14th. So just take note of that. That'll be up on our socials and LinkedIn and so on. In any case, but just so you're aware. With that in mind, let's kick off. So today we're looking at AS2156 Part 2. Last webinar we looked at Part 1, which is in relation to classification of walking tracks. Today we're looking at Part 2, which is in relation to structural design of walking track structures. So structures covered in AS2156, boardwalks, pedestrian bridges, platforms, barriers, etc. that we typically find in the public space. And just to note here that this doesn't include structures intended to carry livestock or vehicles, which would include bicycles and light maintenance vehicles. The objective of the standard is to provide designers and builders with design and construction requirements for non-habitable outdoor structures intended to protect the environment and be used as recreational facilities. Just before we go any further, a little bit of housekeeping, pretty straightforward, or shall I say basic, but we're not Standards Australia. We didn't write the standard, so I'm not going to be able to read into the standard, if you like, and explain the meaning behind a particular clause. All we can do is review what the standard says, and this is not exhaustive. We haven't got time in this session to cover the whole everything in the standard, but we'll just cover what we feel are the pertinent points. And lastly, standards are subject to interpretation. I might interpret it differently to you, and that's the way it is in that sense with standards. And everything we discuss is general. And if you'd like to have a site-specific or project-specific discussion, happy to do so, separately or at another time to this. So, a bit of a general overview to start with. Structures shall be designed in accordance with the applicable Australian standards, and design loads given in appropriate parts of AS 1170 should be used unless otherwise stated here. So that's the first thing to note. 1170 would apply unless this standard states something alternative. Limit state design, serviceability limit state. The structure and its members shall satisfy the serviceability limit state requirements in AS 1170. And for track classes 4 and 5, set serviceability limits to ensure that deflections will not prove uncomfortable and the structure can absorb deflection without causing damage. And then in relation to strength and stability limit states, likewise AS 1170.1, structure and its members should be designed to support the combination of factored loads and forces from that standard, and also follow the live load combination factors in 1170.1. for strength and stability limit states when applicable. So as we discussed last week, or last webinar, I should say, several track classes included in 2156. So today we're looking at the first 5 track classes, so classes 1 to 5. We would, from looking at the standards, would suggest that walking tracks, elevated structures, boardwalks, those sort of things are not applicable to other track classes other than classes 1 to 5. So, class 1 and 2, firstly, according to AS 1170.1, for public assembly areas is the loadings that should be considered for track class 1 and 2. So, and this depends on which part of 1170 I look at, and I would strongly suggest that this is considered in conjunction with 1170. 4 or 5 kPa UDL, so there's slightly different scenarios given there, and a 4.5 kilonewton concentrated load. And also to note, when calculating floor load using 1170.1, the floor live load reduction, given as R, shall be taken as 0. And lastly, the design distributed uniform line and concentrated live load shall be considered separately, and the design carried out for whichever gives the more adverse effect. Now, track classes 3 and 5 have slightly different requirements to class 1 and 2, and also class 3 and 4 have different requirements to class 5. So, firstly, 3 and 4, 4 kPa UDL loading for viewing platforms, and 3 kPa for what's considered an access way, and class 5, 3 kPa for viewing platforms, 2 kPa for access ways. Also, a concentrated load of 1.4 kilonewtons applied over a 75 by 75 millimeter squared area at either known positions, so where that loading would be applied in use or in practice, or if not known, then wherever it produces the most adverse effect. For wire crossings, the live load should be a line load of 1.1 kilonewtons per meter, and as per the classes 1 and 2, the loadings, distributed uniform line, and concentrated load shall be considered separately, and the design carried out as always for whichever gives the most adverse effect. Lateral loadings, lateral loads shall take into account the effects of wind as per 1170.2, earthquake as per 1170.4, and the movement of people. They all may be considered separately. And for the movement of people, lateral load should be taken as 250 newtons per square meter of the planned area of the structure. Snow and ice loads, not common in many places here in Australia, but in some places, as we can see from this picture, this is actually at Perisher. Recommend a site visit. Nice place to head in winter if you like a bit of skiing or snowboarding. But snow and ice load shall be in accordance with 1170.3 for the areas given in that standard, and allowance areas and other built impediments. So the effect of snow and ice build up on wind loads is also needing to be considered. So, for example, if we expect that in a balustrade or a handrail system, ice would render that or make that from an open, shall I say, infill to a solid infill with the build up of ice or snow, then we'd need to consider the wind load accordingly, as if that was a solid item rather than an open infill, if you like. Not sure if that makes sense. Hopefully it does. Design of supports, foundation design based on limit states approach. Use load combinations form 1170.1 for serviceability, strength, and stability. Short-term multiplier is 1. And for design based on nominal loads, refer to the specified nominal loads, clauses 2.3, 2.4, and 2.5, which can be considered separately. Now, just on some barriers, and I'm conscious we're going quite quickly, unfortunately, that's kind of a necessary evil with the amount of stuff to cover here. So, live loads of barriers. Now, live loads of barriers is specified 1170.1 for track classifications 1 and 2, and other classifications would follow this table 1, which is given here on our right. So, And just lastly, I should say, loads of top rail and infill can be applied separately for barriers with infill material. So platforms to class 3, 4, and 5, top rail horizontally, 0.5 kilonewtons per meter, and likewise for vertical, 1 kPa on the infill and half a kilonewton in any direction on the infill also. And then access structures, 0.36 kilonewtons per meter horizontally and vertically, and 0.75 kPa horizontally and 0.25 kilonewtons in any direction on the infill. Load combinations for barriers, design barriers to support factored loads and forces to 1170.1, wind earthquake and load specified in clause 2.7.1 may be assumed to act separately, once again with the design based on the load giving the most adverse effect. And nearly lastly, section 3, safety from falling. Now, we haven't got enough time or room really in this presentation to review this section in full detail. Would strongly suggest you have a look at the effective fall height calculations. This is something we often see catch people out. It's not the right word, but overlook. Needs to be considered in the specific application or the environment in which the structure is to be installed. So in the provision of barriers, effective fall heights given here on the left. Track class 1, 2, 3, 4, and 5 is given across the top, and then various designs of barriers A, B, C, D, etc. are given. Now, also there's a assessment of the impact of the fall impact surface, which, depending on what it is, can be categorized according to several categories: benign, favorable, unfavorable, or hazardous. I won't read the table to you. I'm sure everyone's capable of reading it, but just something to be mindful of there. We need to consider once again the particular environment in which the structure is going to be installed, with a view of working at the full assessment of the full surface. Now, this is a type A barrier, minimum of 1 meters high. We can see some stipulations here around no components providing a toe hold between 150 mil and 760 mil above the deck level. And then in relation to steps, the triangular opening formed by the riser tread and bottom rail at the open side shall not allow the 125 mil sphere to pass through, and also the opening maximum in the type A barrier at 125 mil max. If you're familiar with AS 1428.1, this also may look familiar to you. Type B is similar, however, you can see allowance is made here for horizontal balusters or infill. That often we'd see as a tension wire rope, but it could be a solid member. Same as type A for the steps, and once again, no openings greater than 125 mil, so the 125 mil sphere doesn't pass through either horizontally between the vertical balusters or vertically between what we're calling intermediate rails here. Type C barrier is a much more simple handrail, or a bit like a guardrail as your AS 1657. I should clarify the loading criteria is not the same. So please don't take that as me saying you can use AS 1657 guardrails in this application. That's not the case. That needs to be assessed on its merits, or a handrail system would need to be assessed on its merits. Once again, though, minimum height 900 mil, and we've got our openings restricted at 500 mil vertically, 300 mil at the bottom, with no restrictions between vertical sections, and infill material is allowed if suitable. And then a type D and E barrier, single handrail for a type D barrier, 900 mil height minimum, and type E as a handhold being rope, chain, wire, or separate handholds. Lastly, stairs and ladders. Conscious we're running over time, so I'll try and keep this brief once again. Treads and support structures shall be designed according to the live loads in 1170.1. Ladders and their fixings must be designed for a concentrated live load of at least 1.4 kilonewtons, with spacing determined by expected usage. Stiles should be between 380 and 525 mil, and rungs between 250 and 300 mil apart. And stairways, maximum number of steps between landings as table 4, and landings given as 900 mil long. And we're nearly at the end. This is the second to last slide. Stiles of crossing fences allowed in track classes 3, 4, and 5, not exceeding 1.2 metres in height. This is a section a lot of people are not familiar with. And this is our preferred range here of walkways, stairways, the unsafe zone between 45 and 60 degrees, and then the use of step ladders between 60 and 70, and rung ladders between 70 and 90. And just a note here as far as the applicable classes. So you can see class 2 here below 7 degrees, and then stairways 30 to 38 degrees for class 2, whereas 3, 4, and 5 here, walkways and stairways to 45 degrees, and then our step ladders referred to classes 4 and 5 only, and then rung ladders, once again, classes 3, 4, and 5. That's the end of the session. Sorry, we're slightly over time. Appreciate you joining. As we said earlier, next webinar will be on the 14th of May. We're at Ozwater, not next week, but the week after, when the next webinar would fall, which is the 30th. So if you come into Ozwater, please pop in and say good day, or drop us a note if you'd like to catch up. Any questions, I'll stay on for a few minutes now to answer them, or feel free to drop us a line, hello@treadwellgroup.com.au, or give us a call, 1800 246 800 for Australia, and 0800 244 600 for New Zealand. And once again, understand there was a fair bit of content. If you'd like a copy of the slides, feel free to drop us an email at hello@treadwellgroup.com.au, or if you'd like a link to access the recording, that'll be put up on our socials as well. But you're welcome to drop us an email, and we'll be happy to send you that if you'd like to review it at a later date. .148 here in New South Wales, so I'll stay on for another 2 minutes or so. If we've got any questions, happy to try and answer them if we can. Though, as we mentioned earlier, we're not Standards Australia, so I can't give you the meaning behind the standard. All we can do is assist with interpreting or understanding the standard and to what it would apply. Doesn't seem to be many questions coming through, so got one through. Oh, yep. G'day, Jeff. In relation to barrier loading for track classes 1 and 2, that refers back to the loadings given in AS 1170. So we looked at those in a separate webinar. If you'd like to discuss that, just drop us a note, hello@treadwellgroup.com.au, be able to set up a time to discuss, or send you the link to the webinar where we looked at the barrier loadings as per AS 1170, but the track classes 1 and 2, the AS 2156 refers back to AS 1170, as also it does with the floor loadings. Question in relation to the ground investigation requirements. Look, that's not a question I can answer here. That would be very dependent on your structure and your location. I would assume that most structures would require some sort of geotech investigation to be done. That would be the responsibility or the scope of a geotech or civil company, which is not us. So sorry to not be particularly helpful, but I can answer the ground investigation requirements. in relation to a particular project here and now without knowing more info, and that would be on a site specific basis. Looks like that's it. Thanks for joining again, everyone. See you on the 14th. And in the meantime, look forward to having a look at the results from the poll. Always glad of suggestions on future topics and glad of feedback. This session put you to sleep, then please let us know. Sorry about that. If it was worthwhile or of value, also glad to hear that sort of feedback. We want these sessions to be informative. Thanks again for joining. Hope you enjoy the rest of your day and your week, and we'll see you again on the 14th. In the meantime, if you're coming to Ozwater, please pop past and say good day. You'll find us straight inside the far right entrance door. I think I can't remember the door number, sorry, but hopefully we'll see you there. Thanks again. Cheers.